We are now starting Unit 11, and this is on probability and statistics. So we're going to start today with 11.1 Day 1, which is part 1 of 3, dealing with the fundamental counting principle, permutations, tree diagrams, and factorials. So let's get some vocab out of the way. Our first one is our fundamental counting principle, and this just simply states that if we have A and B are finite sets, finite opposite of infinite, there is a limited number. The number of ways to choose one element from A and then one element from B is going to be taking that number and multiplying them together. And we're going to take a look at some examples, so I won't get too much into examples right now. A permutation is going to be that selection of a group of n objects in which order is important, and the objects are chosen r at a time. So our formula we're going to use when we get there is capital P with little n and little r subvalues on the sides is equal to n factorial divided by n minus r, the quantity factorial. Factorial, we've talked about these a little bit in class, and a factorial is going to be that product of the natural numbers less than or equal to the number 0 factorial is defined as 1. And that means simply put means that, for example, if you have 6 factorial, you take 6 times 5 times 4 times 3 times 2 times 1. So you take all of the numbers from the number that's next to the exclamation point and multiply them all the way down to 1 and get the product. And we're also going to look today at how to use a graphing calculator to be able to get this information. So our first part is taking a look at using the fundamental counting principle to find the total number of possible outcomes. So as you can see here, it's a little bit small. We have a lunch special, and you can choose one entree, one drink, and one side dish. And we want to know how many meal choices there are. So if we look at this menu here, we've got that we have entrees of pizza, chicken, or beef, side dish of coleslaw, salad, or fruit, and drink options of milk, punch, juice, or iced tea. So, for example, we could choose pizza, a salad, and milk. That's one option. Now, one of the big difficulties here when we're talking about number of possible outcomes is if we just go about listing them, then we're going, did we miss one? Did we double up on one accidentally? So, using the fundamental counting principle, we're going to go about the route of saying, all right, I see that I have 3 possible options for my entree. And for my side, I have 3 possible options. And for my drink, I have 4 possible options. So I'm going to take these and I'm going to multiply them. And 3 times 3 is 9, 9 times 4 is 36 possible meals. One thing you're going to discover really quickly is that almost all of your answers, when we deal with probability and statistics, will have labels on them. So please make sure you don't forget them. Moving on to the next example, we have that in Utah, we've got license plates consisting of 3 digits followed by 3 letters. In Utah, they do not use the letters I, O, and Q, and each digit or letter may be used more than once. So we want to know how many different license plates are possible. So what I like to do is look at it and say, well, I've got 3 digits followed by 3 letters, and that's a hyphen, not a minus sign. And when I look at this, I say, well, I can use any digits. Remember, you can use 0, so that means 0 through 9, 0 through 9, 0 through 9. And then we have the letters on minus I, O, and Q. So A to Z with no I, O, or Q for all 3 of these. So then we need to look at how many options are there in each spot. So 0 to 9, that's 10 options. 0 to 9 is also still 10 options, 10 options. We're going to multiply those. And then A to Z is 26 letters, but we're not using 3 of them. So that would be times 23 times 23 times 23, because it is possible to say have 111-AAA. Not real common, but possible. So in doing so, I'm going to use my calculator just for number crunching purposes. If we take 10 times 10 times 10 times 23 times 23 times 23, we get an answer of 12,167,000 different possible license plates. And I'm going to just abbreviate